For this video, I'm going to go through some of the utilities that I mentioned at the end of the last video. So I'll break the utility stuff up into a few videos. This isn't going to be very long. I'll try to make this just a few minutes each. So we'll go utility coordinate conversion. And this is actually, you can choose lat long. You have to select lat long here. You can put whatever your UTM zone is. And then all you need to do is put in lat long coordinates here. And I believe you can actually put these in a couple of different, in the multiple formats, but I need to look into that. So if you just, I'm just going to go with the example coordinates they have in here. If you're going negative 114, 37, 4, and 52, 48, 50, and then you just hit apply, it gives you the UTM in meters, X, Y, or lat long. So I think if you do this, and yeah, you can actually enter the UTM X, Y as long as you do UTM zone in that as well, and then it would go back to giving you lat long as the output. And then let's see, for the next one, the utility survey information, there's a kind of a lot to digest here. So if you are not using, I prefer to use a survey design to like build receiver in well or build shot in well or on surface. But you can also build a lot of those things through the survey information tab utility here. So you can go geophone, number of geophones, and put it at feet, say you have left-hand Z, and then if you just do output, just do dummy.receiver.rnf, then you can do define, and it'll give you a way to define the receivers. And as you can kind of quickly see, you can obviously do the XYZ, but without having something to calculate the dip azimuth or the measure depth. If all you have is, I mean, I guess you should have measure depth anyways, but without something to commit to calculate the dip or azimuth, if you don't already have those, you're going to have a tough time with that. So let's go. So geophones or information. Let's close that. So our utility. And then you could do geophone like I showed before. You could do geological mark. I haven't really used that too much, but you can put geological marks in there. Well, you can define the number of points per well and do well info. So you can just do a dummy well here too. And it generates this into .3 well format. So then you can define that. Once again, if you have a well surface location and you're treating it as a vertical, you could probably do this with just 2 or 3 points. But otherwise, I think importing the well into the survey design, as I showed you earlier, is probably a better way of doing that. Calibration, you can do the number of geophones and define. So this is an RCV. So this actually is something we talked about before. If you had, if you already have geophones that you know what the rotation angle is, rather than, so we talked about this before. I did the tests. I need to redo the tests because I did them and I don't think I actually gave you guys the feedback on whether or not you could export the seg-y, then bring it back in rotated condition. But this actually sidesteps the necessity to do that. If you already have the rotation angle and you have the XYZ, then you could import the rotation angles into here. But I still need to do the seg-y rotation task. So then you can define import, save. If you import, you can bring in the number of header lines, and you got the XYZ column. So then if you're bringing those in, you can import them that way. If you have the rotation angles from a secondary source, you can input those here. Let's see, build perforations. That goes to a different window again. So hang on. And then so you got calibration, build perforations, and well, you can input the well here, much like you can do in the survey design. You give it the number of perfs and measure depth in the interval, and it'll build it. And then you can do the output perforation file here for an orientation shot, output shot file. And then you can define the shot info in here. I haven't really had to use it very often. In general, the projects that we handle here have known locations of perforation, so I haven't had to do that too much. Stage here, number of stages by time. This is kind of if you're setting up a huge job, you can just do obviously you would call it the 1H well or whatever you're doing. Call it a dummy here, and you can define the number of stages. So you got 15 stages. You can define those, and then you come in here, and you can do this stage names, the date, start time, end time, start XYZ, end XYZ, So these are, when it says start XYZ and end XYZ, this is just a way of doing extents of the perf intervals. So this would be the min and max XYZ based on what the first and last perf within your stage is. Let's see if we have anything else to do here. No, that's pretty much it there. So let's go to the next thing in the utilities, which is the velocity calculation, VP/VS ratio calculation. So you can input a velocity model here, and you can input an S velocity model here, give it the depth range you want. You can make it, I don't know I think if you have to just go 0 to the end to default it to everything, and you can the output velocity model there, and it'll calculate the VP/VS ratio. I mean, obviously, if you can also do that in a kind of in a text file and build it in. But this is a simple way. If you don't want to, if you have the VP/VS but you don't have the calculated ratio for a given log, you can calculate the ratio here. And I don't think I've had to use the bulk shift, but you can bring in the input, the original velocity model, they updated, select this depth range for bulk shift, and then output that. I haven't had to do a bulk shift very often. If I do, I just generally shift the logs in my survey design, my model building phase. So event restoration is kind of a cool, it's kind of a cool thing we have here. If you put the input event file in here, and then you put the output event file, you can restore to the origin. So in other words, if a project was processed in a certain coordinate system, say even in a local coordinate system, and you don't and you need to put it in a global coordinate system, or vice versa, if you did it in a global and then you want to output it in a local for some reason, you can put the input and output event files here, and then you can use this to shift the coordinates. So I've never used it, put it back in a relative, but I have just processed a project in a relative coordinate system before, and then transformed it to a real world coordinate system. Usually, the reason I have to do that is if somebody changes their mind about what coordinate system they want it in to begin with. Sometimes if I already did it relative, I'll switch it to that. If they tell me that they don't know yet, or sometimes I've actually had to switch from one coordinate system to another as well. So it kind of takes an intermediate step, but that's doable as well. So that's all I'm going to cover for here. I'll come back on the next one of these videos and cover a few more utilities. Thanks.